All right, in this lesson, we're going to learn how to solve ratio problems. Now, you may have done this, you probably did this in middle school, but now we're going to do it with triangles. You certainly learn how to solve ratio problems with proportions. But these are all, the front page is all done for you. They're just examples for you to look at. We're really going to do the second page on video here. Nice short video, hopefully. But you could see how we have similar triangles, and when you have similar triangles, you have sides proportional, which we talked about in our last lesson. So AB would correspond to ED, right? So AB corresponds to ED. And then BC corresponds to DC. So BC corresponds to DC, right? So 5 to 2. You could do a 5 to 2 ratio. So you could do 8 to X equals 5 to 2. For example, all right. Now, and then here we did 2 to 5 equals X. They did 2 to 5 equals X over 8. It's the same thing. I just had the bigger ones on top and the smaller ones on the bottom. They did small on top, big on the bottom. But that's the idea, and that's what they're explaining here without me reading this to you word for word is, if you do small over big or big over small, as long as it's consistent, you will have a proportion that works. You have to use corresponding sides to make your proportions. Here's another example for you. Small over big equals small over big. Small over big equals small over big. And then you solve the proportion. Here's another one. Small over big equals small over big. Okay? And this one they broke up where the big side was 2 plus X. And we're going to do an example like that, actually. Okay? So, let's get to it. So, first of all, to understand the corresponding pieces, we got to figure out what happened here. How did the purple get to the orange? Looks like it got bigger, obviously, right? But it also rotated. How do I know it didn't reflect and how I know it rotated? Well, see this little star here and this little star? They're showing you that that angle corresponds to that angle. If it reflected, if it was a don't draw this. If it was a line reflection, then this one would correspond to this one. It didn't flip over the line. It rotated around the center. It rotated around the center. So I know that this is a rotation and then a dilation, or vice versa. Dilation, then a rotation, whatever. All right. So what are my corresponding pieces? Well, I know B corresponds to D. That means that E must correspond to A, because obviously C corresponds to itself. Okay, so now I can write my proportion. I know that 16 corresponds to 24. That's obvious. Okay, but let me do it like this. Let me do big to little. So I'm going to do big over small. Okay, so I'm going to do 24 over 16. That's a corresponding side, right? 24 is to 16 as... and now I want to solve for y. So I'm going to do 18 is to y. Because I know that this side corresponds to this side if it rotated. Okay? So now I just solve. You cross multiply. 24y equals, and 16, so you cross multiply. 16 times 18 is 288. I did this ahead of time to save you time on your video here. Divide by 24, and y equals 12. So I know that this right here, I know that this y right here is actually 12 now. Okay, so now I'm going to switch colors, and I'm going to find my x. Here's my x, and that corresponds to the 10. So I'm going to go 24. Now I'm just, for the heck of it, I'm going to do small over big. That's just the way I did it. You could do big over small again. It doesn't matter. But if I do small over big, it's going to be 16 over 24. Small over big. 16 over 24 equals, now I'm going to do small 10 over x. Because I'm trying to find the larger side, the side of the larger triangle. So now I cross multiply. 16x equals 240. Divide by 16, and x is 15. So I know that my x right here is 15, and I have all the sides of my triangle. I have this one side of the purple and the one side of the orange one that we were missing. Again, given two similar triangles. Now what happened here? Now this one, because see this one goes to here, this one does look like it's a reflection. There's a reflection over some line here, right? So there is a reflection and then a dilation, or vice versa, a dilation and then a reflection. It doesn't matter. Okay, so this 12 corresponds to the 15. So I have 12 over 15 equals 15 over x. Now, where did I get this? This is 12 to 15. So it's this 12 and this 15. That's these. 15 over x, 15 over x. They correspond. See how I did small over big? So I did small over big. All right? This is 12x equals 225 when I cross multiply. Divide by 12, and it's not going to go in evenly. It doesn't matter. X is going to give me 18.75. So I know x is 18.75. And then I'm going to change colors. I'm going to find y. Now y corresponds with this one here. Those correspond. All right, so I'm going to do y over 20. So I'm doing small over big again. Small over big equals small over big. I'm going to do 12 over 15 again. Might as well go with what's given. 15y equals 240. Divide by 15. Y equals 16. Y equals 16. So we know that this must be 16 length. All right. So now, this one here is a little different. It's a triangle inside a triangle because the only thing that happened here was a big D for a dilation. That's all that happened. Just blew up. Dilation. There was no reflection, no rotation, no translation. Just a dilation. When that happens, you'll get a triangle inside a triangle. What I want you to do, and like you saw on the front page, I want you to separate. So we have one triangle here. We have one triangle, the smaller triangle, that does this. Okay, try to separate, try to keep the same shape the best you can. I don't know, I didn't do a very good job of that. And there we go. So we got A-R-T. A-R-T, right? And that's 10 and 8, and we don't know we know why, right? So now, the big triangle, if you're careful, the big triangle, same shape, just a bigger size. That's A-E-D. Okay? A-E-D. That's, now, the whole AE, if you look closely, it's 8 here, but it's 2 here. 8 and 2, it's actually 10. That's actually 10. Okay? This is 15. That was given, right? DE is 15. And AD is 10 plus X. So we're going to call that X plus 10. AD is X plus 10. So now, when we go to find Y, it's going to be pretty easy. So to find Y, it's going to be 10 is to 8. So we'll do that one is to that one. 10 is to 8 as, we'll just do 15 is to Y. 15 is to Y. So that's an easy one. 10Y equals 120. And then divide by 10, Y equals 12. Okay, so Y is 12, and that was easy. Now, not that this is hard, but you do have a binomial here, x plus 10. You got to do a little algebra. Oh boy, algebra. It's been a year, Mr. Veteran. I can't do algebra. Yes, you can. All right, so now we're going to do the same thing. 10 is to 8. 10 is to 8 as this x plus 10 is to 10. This 10. See how they correspond? You got to use corresponding sides. Corresponding sides. We've been doing that all year. Corresponding sides. All right, so this is going to be 100 equals, and this is going to be 8 times x plus 10. Oh my goodness, we have to use the distributive property. It's been so long. So 100 equals 8x plus 80. Subtract 80. 20 equals 8x. Divide by 8. 8 doesn't go into 20, but that's okay. X equals 2.5. X equals 2.5. Done. That's it. I'll see you for more practice tomorrow.